Hey class, we're going to do something really fun today. We're going to be working with exponential and logarithmic relationships. That's kind of like a game. We're going to learn some basic logarithmic properties. That's kind of like the rules. And then when we evaluate the logarithms, we'll be playing the game. I think it's awesome. Come on, let's go. So, part of this game is that exponential equations such as a base raised to, that's a base, raised to an exponent is equal a number. It has a relationship with a logarithmic equation. If I take the log of that base, that's the same base as in the exponential equation. Log of that base, log base of that number, that's going to equal the exponent. So we can rewrite all these wonderful things. Let's take a look at these. Like 2 to the 5th is equal to 32. 2 is our base, so we're going to write it as log base 2 of, and the 5 and the 32 are going to trade places. Of 32 is equal to 5. You want to try the next two? Go ahead and pause and try it out. So did you get this? Log base b, or log base b of 27 is equal to 3, and log base e of 33 is equal to y. I think you probably did. Let's take a look at this next one. Let's go the other direction. We're going to take a logarithmic equation and rewrite it as an exponential. So this 7 is our base, 7, and the x and the 3 trade places. So it's 7 raised to the third power is equal to x. Hey, pause this and try the next two. I'm sure you're already caught that this is our base, and the 5 and the 2 trade places. Oops. B squared equals 5. And then this last one, 4 to the y power, is equal to 26. Good job. Let's look at a few rules. So we're going to start out with some basic properties of logarithms. And hopefully we work with them enough, just like the rules of a game, that when we play the game enough, we know all those rules. So we're going to learn these rules by playing the game of evaluating our logarithms. The rules are here. The first one is log base b of b is equal to 1. Let's put that in numbers so it looks similar, or so we can see it. Log base 5 of 5 would be equal to 1. Now if I rewrote that as an exponential, that would be 5 raised to the first power equals 5. Well, that makes sense. No wonder that works, right? Let's take a look at the next one. The base is b. Log base b of 1 is equal to 0. So with a number, it doesn't matter what b is, could be 3. Log base 3 of 1, it still will always equal 0. Why? Because any number raised to the 0 power is 1. Oh, okay, that makes sense. Let's take a look at this one. Log base b of b raised to the x. Hey, that equals the exponent. Well, let's take a look at something with numbers. Log base 4 of 4 squared is going to be 2. Well, if I rewrote that as an exponential equation, that 4 is my base. This 2 is the exponent. And that's the answer. Oh, well, that really makes sense. 4 squared is equal to 4 squared. That's common sense, right? Oh, now this one looks a lot different. Log raised to the log base b of x is equal to x. Let's put some numbers on that. 7 raised to log base 7 of 2 is going to equal 2. That looks really funky, but let's look at it as an exponential equation. 7 is our base, raised to the second power. Oops, I'm sorry. Let me erase that because I don't want that part. I did that wrong. We're going to a logarithm. 7 is our base, log base 7. 2 is our exponent of 2 is equal to the exponent. Oh, well, the exponent is log base 7 of 2. Of course that makes sense. Yay. All right, I think if we get these down, we're ready to play that game. All right, so here's the game. We're going to be evaluating these logarithmic expressions to get them into the simplest form possible. Hey, if you think you know what you're doing and you want to play this game without me, turn it off and try it out and then check your work. All right, so whether you're checking your work or you're going, I need a few examples, let me see. Here we go. I'm going to rewrite this so that this becomes 10 squared. Because you know what happens then? We have that, it matches that rule, where the base and that match. So now it just equals that exponent here of 2. Oh, that's probably pretty simple as I can get it. All right, let's see if I can do that with this. Can I write 125 as a 5? Well, I know 125 is 5 cubed. Can I write that where 5 is the base? Yeah, because if I make that a negative exponent, that means it's, in the denominator. So I'm going to rewrite this as log base 5 of 5 to the negative 3, so that it equals that exponent of negative 3. And our last one, ooh, this is a little trickier. Can I write 6 as something 36? Well, let's take a look. If I put 36 equals 6. If I put a square root, that's a true statement now, right? The square root of 36 is 6. I could also write this as 36 raised to the 1/2. So now I have 6 written where 36 is a base. I'm going to substitute it for that 6. I'm going to rewrite it log base 36 of 36 raised to the 1/2. And that's going to equal that exponent of 1/2. Did you enjoy playing? I think it was fun. You all did a wonderful job on this great game of mine. I love it. Well played. Enjoy.